figure. What do you want to match up next? Look at your shapes. Pick a shape that's on your board and tell me what you wrote about it, Aurora. A rectangle. Okay, so I'm at the rectangle. It does have 4 right angles. It does have 4 right angles. So does the what? So does a square. Okay. A square also has 4 congruent sides. Okay. Oh, my screen is frozen. You guys, sorry, I unfroze it. Okay. What else? One set of parallel sides. That's a trapezoid. And that's letter choice C. Is that true for both the trapezoid and the isosceles trapezoid? It is. Okay. A rhombus has 2 sets of parallel sides. Is that true? It has 4 sides congruent. What can we say about a parallelogram? What makes a parallelogram a parallelogram? 2 sets of parallel sides. Okay, so that's A. What can we say about that isosceles trapezoid? What is it missing? What gave it the name isosceles? One set of congruent sides, just like an isosceles triangle, an isosceles trapezoid has 1 set of congruent sides. Okay. I think that we're missing something for our rectangle. Huh? 4 right angles, we've got that. E. 4 sides, we've got that. What? 2 sets of parallel sides. Oh my goodness. So that means that a rectangle is a type of parallelogram. Oh my goodness. Say that again, nice and loud. A square would also have 2 sets of parallel sides. That means that this is also a type of parallelogram. Okay, what about the rhombus? What are we missing on our rhombus? It has 4 congruent sides, B. It's something that you said, Braden, but you were challenged out. Braden said it at the beginning, and I said, really? Does it? And you said, no, it doesn't. Yeah, it also has 2 sets of parallel sides. So that means that a rhombus is also what? It's a type of parallelogram. Okay, so here's what I'm going to write. I know that a parallelogram has 2 parallel sides. I'm just going to write a little note off to the side. And that means that a rectangle has 2 parallel sides. And so does a rhombus, 2 parallel sides. And so does a square, 2 parallel sides. What about the trapezoid and the isosceles trapezoid? How many parallel sides do they have? Just 1 set, right? Didn't we say that? Just 1 set of parallel sides? So I'm going to write that as well. 1 set of parallel sides. 1 set of parallel sides. And there's a reason that we can do this. So all of our quadrilaterals have 4 sides. So every single one of these shapes is a quadrilateral, but our quadrilateral can actually be broken into 2 or 3 categories. Let's see. We could have quadrilaterals, and then inside of it is all of the parallelograms, because they have how many pairs of parallel sides? 2. So like you have quadrilaterals, and then below that you have like things with 2 pairs of parallel sides, things with 1 pair of parallel sides, like trapezoids, and then what was that other shape that we didn't give any parallel sides to? The thing that you fly in the spring? Kite. A kite. No parallel sides. Okay. It's just an idea, but I think we're going to make a chart. Which description did we use the most? 4 sides, yeah. F. We used F the most. 4 sides. Y. Yeah, it's the most basic category. For a 4-sided polygon. It's the most basic name for a 4-sided polygon. It's just a quadrilateral. That's what we call a polygon with 4 sides. We just call it a quadrilateral. Nothing special about it. Why do you think some shapes have more descriptions than others? Huh? Okay. So you go from basic, which is 4 sides, to more specific, like parallel sides or congruent sides, right? So some of them are basic and then we get more specific. Parallel sides, congruent sides. What shape had the greatest number of descriptions? A square. Why? Okay, so let's see. What are all the things that a square is? So it's a parallelogram. It has 4 right angles. It has 4 congruent sides. So it's probably the most specific. It's the most specific one that we talked about. It kind of has all of the properties that we talked about independently smushed together, right? Has parallel sides, 2 of them actually, 2 sets. Has right angles, all 4 of them. Congruent sides, all 4 of them. So it has all of the things that we talked about plus all smushed together. There were 2 shapes that we couldn't do anything with. We just called them quadrilaterals. And those were the 2 shapes that we just called quadrilaterals. How are they the same? And how are they different? So it looks like they have parallel sides, but they're not marked like that. If it did have any parallel sides, it would either go in the trapezoid or the parallelogram. Does that make sense? So these don't have any parallel sides. How are they the same? What makes them the same? 4 sides. Yep. That's what makes them the same. 4 sides. How are they different? What does that mean when it's caved in? You guys ever sat on a cardboard box and it like smushes, right? You go to sit on a cardboard box and the side of it smushes in. It looks like the one on the left is smushed. It looks like I sat on it, squished it in. What's that called? It just went inward. It's got a special name. It's called concave. Have you ever heard that? This is concave because it's caved in. This one is convex. That's how they're the same and that's how they're different. Okay? So I'm going to talk about the convex shape for a second. If I were to pretend that I had a ruler, and I just took every line segment and extended it, I'm just going to make these a little bit longer, extend my lines a little bit, extend my lines a little bit, extend my lines a little bit. No matter how long I make my lines, do the lines ever go inside of the shape? Meaning, no matter how long I make these, do they ever get inside the space? No. That's what convex is. The lines never cross inside the shape. The segments that create the shape, if you extend them, never go inside of it. What if I were to do that same thing to this? So I'm going to extend this line, and I'm going to extend this segment, and I'm going to extend this segment, and I'm going to extend this segment. What do you notice? Well, when I extend the segments, they actually go through the shape. They cut into the shape. They cut into that shape. And I would highlight that so you can see what's happening. That's what makes a shape convex. When you extend the lines, and they actually go through the shape. And they do that because it's caved in. Okay? Typically we can look at it. And see, oh, that's caved in. But sometimes it's a little hard. Sometimes you might have to draw some extra lines to see what's really happening. Okay? Alrighty. We're going to draw a picture on the back. We're going to draw a fabulous picture on the back, a diagram, and then we're going to move on. Okay? Well, we're going to do number 1 on the back as well. The sometimes, always, never. But I want to draw a diagram in our little quick notes because I'm a visual person. And so I want to draw some kind of picture that helps me understand the quadrilateral hierarchy, meaning kind of like how are quadrilaterals categorized, okay? So I'm going to start with the most basic, which we said is a quadrilateral. And this just is a shape with 4 sides. That's all. It's just a polygon with 4 sides. Okay, this is on the next page. We're going to start with the quadrilateral. Just had 4 sides. And then if you think about the front, when we started sorting those, I said we could actually break that into how many categories? We can break it up into 3 categories. 3 categories. The first one was parallelograms. And that just means they have 2 sets of parallel sides. Then we had this category of trapezoids. And how many parallel sides does a trapezoid have? Just 1 set of parallel sides. And then our other was actually called a kite. And a kite has no parallel sides. So 2 sets of parallel sides, 1 set of parallel sides, no sets of parallel sides. Does that make sense? How we are going to break our quadrilaterals up? How we're going to think about them? Okay, so in our quadrilateral zone, we had quadrilaterals with 4 right angles and quadrilaterals with 4 congruent sides. What quadrilateral had 4 right angles? A rectangle. What quadrilateral had 4 congruent sides? A rhombus. What quadrilateral had both 4 congruent sides and 4 right angles? A square. And then when we think about our trapezoids, the 1 set of parallel sides, we also had an isosceles trapezoid. It had a set of parallel sides and it had 1 set of congruent sides, right? So I'm going to freeze that. I'm going to kind of scoot it over just a little bit, possibly, because you pretty much already have the stuff for the kite down. And I'm going to make that a little bit bigger, and I'm going to freeze that for a second. So your quadrilaterals are broken up into, are you playing with us today? Okay, just checking. Quadrilaterals are broken up into we break it up into 3 categories. 2 pairs of parallel sides, 1 pair of parallel sides, no parallel sides. 2 pair of parallel sides, well, that falls into the parallelogram set, right? Parallelograms are things like rectangles, rhombuses, and squares. No, 1 pair of parallel sides is a trapezoid or an isosceles trapezoid, and no parallel side would be a kite. You with me, Anderson? Okay. What is one thing that we know about our kite? Because I don't think we wrote anything about that kite other than it doesn't have any parallel sides. Go back to your little picture of a kite. There was something marked on our kites. Do you guys remember what the markings were on our kite? How many pairs of congruent sides does it have? Yeah, I'm going to write that. A kite has 2 sets of congruent sides. Raise your hand if you need more time on that. Filling that out. Okay? Good? Everybody's good with that? Still working? Okay. So this is called a quadrilateral hierarchy. It's kind of how things break down. So we're going to do this check your understanding down below using always, sometimes, or never. Siempre is always. Como se, and nunca, never, right? Como se dice sometimes?
Debes.
Debes.
En cuando.
En cuando.
Or
Debes.
you can say algunas veces. That might be easier. Algunas veces.
Algunas veces. Algunas, every time?
Or
some. Algunas means sometimes?
Sometimes.
Okay.
De vez en cuando is like a time.
Will you write down sometimes on the board for me? Okay. So, no, siempre, y nunca. All right. A square is always, sometimes, or never a rectangle. I want you to see where the square is. What made a square? A rectangle and a So is a square a rectangle? Always. Siempre. Siempre. Always. So this is always. A square is always a rectangle. Okay. A parallelogram is always, sometimes, algunas veces, or never, nunca, a rhombus. Is a parallelogram always a rhombus? Never a rhombus? Sometimes a rhombus. Sometimes. Good job. Sometimes. Algunas veces. Algunas veces. A trapezoid is a rectangle. Never. Nunca. Never. A rhombus is a square. Siempre, always. Sometimes, algunas veces. Never, nunca. Let's see. Let's go back to our chart really fast. What is it asking me? If a rhombus is a square. What makes a rhombus? Has 4 congruent sides. What makes a square? Has to have 4 right angles. Does a rhombus have to have 4 right angles? No. Could it have 4 right angles? Yes, but it doesn't have to. So is this sometimes? Algunas veces. Okay. A rhombus is blank a quadrilateral. Never, nunca. Whoops, lo siento. Ah, ay caramba. Is a rhombus always, sometimes, never quadrilateral? Always, siempre. Always. Right? Quadrilateral means it just has 4 sides. That's always true about a rhombus. Okay? All right.